I'm going to introduce to you a new tool. It's called Concept Mastery. This morning we did the Concept Mastery routine, and that routine involves the teacher really thinking through what is a critical concept for the course. Does anybody have any idea what I mean when I say a concept? What do you think a concept is? So often kids think they have an idea, but they don't really know it. They can't really nail it. And concept mastery allows kids to do that. A concept is a big idea, and it's something, there's not that many of them, but there's some really big, hard ideas in science that you're working with. How many of you have heard the word force before? Have you been talking about force? Okay, so I just want to introduce you to this tool first, and then we're going to start talking about force. What does that say at the top? Concept diagram. What we're going to do is talk about what you already know and come up with a definition. Our task was to help kids really understand the concept of force. So we identify what's the overall concept. So we said force is a principle of physics. So we're going to write that here, because this is a bigger idea. Then we have the kids brainstorm, and we came up with a list of everything that they could tell us about force. If you have a push and a pull, what other ideas come to mind when you talk about force, if you remember?
That it's measured in newtons.
It's measured in newtons. Nice job, thank you.
Balanced or unbalanced?
They can be balanced or unbalanced. Yes, ma'am?
Net force.
There's a net force. Okay, what is a net force? Anybody know what that means? As we looked through what the kids brainstormed, we then talked about all the characteristics and sorted them. And we decide, what are the always present characteristics? So what makes a force a force? What's sometimes there and what is never there? And what it does is really tightly defines what that concept of force is. Now, what we have to do is apply it. All right, well, what does this really mean? So I'm going to give an example here. Then we give the students an example, identify it, and say, okay, how are we going to think this through? Picking up a pen or pencil, just take it, okay? Take your pen or pencil, just set it down. Now all I want you to do is pick it up to eye level. Why is that an example of force? Yes, ma'am. And then after we've done it and modeled it with the kids, we give them a concept. How many of you play soccer? Or ever played, okay, a kickball? Kicking a ball. So there's your scenario. I want you to think it through. And I also want you to tell me now, not just is it or isn't it, but how did you think it through? I want you to be very aware of how you're thinking. And then we teach them about thinking about concepts. It's a very powerful routine because we can show kids that anything that displays these always present characteristics is then a force.
Since it's moving, it would be an unbalanced force. The pairs would be friction because of the air. There's that water friction.
It doesn't matter if it's in motion because you got one that force pushing.
Good thinking, yes. And then the routine ends with showing kids how to tie it all together. So we start with the big idea of what's force. Through the lesson, we completely pull it apart, find out what they know, find out what they don't know, find out what their misconceptions are, talk about examples, and then we pull it back together by showing kids how to develop this definition. Force is a principle of physics, and we have to include in our definition all of the always present characteristics. Force is a principle of physics which always has a push or a pull that works in pairs, acts on matter, and creates a net force. I'll often tell a teacher, try teaching a concept to one class the way you would ordinarily do it, and then use a concept mastery routine with another class. Is that much more understandable now that we have worked it through? And just assess for yourself. I think it has a powerful effect when teachers take the time to do something like that, to actually sit down and devise an assessment to prove it to themselves. All right, you're going to get something that looks like this. What does that say at the top? Concept diagram. All right, and you see there's a lot of lines and circles on there. What we're going to do is talk about what you already know and list it, and then figure out and come up with a definition. What I want you to do right now is turn to your partner, and I want you to just check with your partner what they know about force, okay? Just brainstorm for a minute. Think about it. What do you know about force? Turn to your neighbor. I'm going to give you about a minute to do that. Can it be pulling too?
Yeah. Can it be for science to be pushing or pulling?
Pushing or, oh good, okay.
Push or
Okay, very good. So anything else? What does force do for us?
makes us move.
Okay, so there's some motion involved. Okay, good. Don't write anything down yet, okay? We're not going to write anything down yet. I just want you to talk so that when we share, you have something to say.
Explain it. No. I'm confused.
Now, some of you were saying force can be a push or a pull, and what we're going to do is start a brainstorm list of some of the things that you already know about force. But what I want to tell you here is that force is one of the principles of physics. Anybody heard of physics before? Okay. What is physics the study of? Anybody know? You've heard of it. What does it have to do with? Physics, physical, forces. Forces are certainly going to be a part. It's one of the main principles. Yeah.
Would it be motion?
The motion has something to do with it. And maybe Mrs. Morgan could help us here, but I think it's got to do with the properties and laws of conservation of energy. That's part of physics. Nice job.
Matter.
Matter is going to be part of physics. You guys are giving great examples of parts of physics. But physics is the big picture of the study of the physical world or laws and properties of the physical world. And it gets pretty complex. And you're going to get a really good basis in it so that when you go to high school, you're going to be more prepared. If you can go into 9th grade knowing what force is, you're going to be a step ahead. So what we want to do is know that force is a principle of physics. So we're going to write that here because this is a bigger idea. Now there's other principles of physics, like there's 3 of them, correct, Mrs. Morgan? Force, motion, and energy. So you're going to be studying those other ones. Have you already studied one of those? Which one? What have you already studied? Energy. Okay, so now we're moving on to force. So it's another principle of physics. So you had some time to talk with a neighbor. We're going to brainstorm a list now. So what else? You have a push and a pull. What other ideas come to mind when you talk about force? Do you remember?
That it's measured in newtons.
It's measured in newtons. Nice job, thank you.
Balanced or unbalanced?
They can be balanced or unbalanced. Everybody knows what balance is, right? Yes, ma'am. There's a net force. Okay, what is a net force? Anybody know what that means? What is the net force?
Newtons total.
Yeah, well, it's like what's left over. So, okay, you have, and that means what's left over because you have, if you have 2 things pushing and pulling, if you have 2 things pushing against each other, whatever one's stronger is going to push it, right? If they're equal, then what kind of force would they be? No. Would they be balanced? They would be a balanced force. All right, what else do you know? Let's get some other ideas down. I asked you to think of an example of force. Can anybody give me an example? Yes. Pushing a car. Okay, like by hand pushing a car. Okay, that'd be pretty tough, wouldn't it? Yeah.
If you're walking your dog and your dog is pulling you down the street.
Oh, nice example. Nice example. Okay, good job.
Gravity.
Gravity. Is gravity a force? Gravity's got something to do with this, doesn't it? Oh, you guys know a lot already. Anything else that you want to share with us? Any other ideas?
Yeah, like if someone with more mass pulls something, it'll be easier than someone pulling something that has more mass in it. Like 2 kids in a car.
So mass is related in some way. Okay. So we have to sort these ideas. All right? And some of them are always, always present when there's force. All right? Some of them are sometimes present. And I don't think we have any never present here, do we? We'll help clarify that for you. So what here is always present when you have force? Friction. Friction. Is friction always present?
Friction. Is it possible to have a force without friction? Okay. So does it always have to be there, or is it sometimes there?
What would be an example of a force that doesn't have friction? Would that be like out in outer space, or is there an example of that on Earth where there wouldn't be friction involved?
I think you're stumping me. I can't.
Most of the time on
Most
Earth
of the
there's
time
friction,
there's friction.
but it's not required, is it?
Right.
All right, so let's put on here that this one is sometimes present. That friction, and on Earth it's usually present, and probably though in a lab where they're studying force, they can probably make an experiment like at one of the universities to take away friction when they're really studying it carefully. So, yes?
Gravity?
Gravity. Would gravity always have to be present to have force? What do you think? Does gravity always have to be present? This gentleman.
Well, it depends on, because gravity pulls the object you're pushing and makes it heavier. So you have to apply more force to it.
On Earth, is gravity always present? How do we want to approach that, Mrs. Morgan? What do you want them to understand about the gravity piece?
Friction and gravity are both types of forces.
Okay.
So if we're looking at the word force, we could say, yes, friction and gravity would always be present in some kind of interaction on Earth. But the concept force is kind of bigger than friction and gravity. Those are examples, but it's hard to separate stuff out.
That's a good way of putting it, because friction and gravity are kinds of forces, but then we can also give examples of friction. When a car goes on the road, there's friction with the tires against the what? Because whenever two things are going against each other, it causes a force. So we could put, we're going to hold on that, but friction and gravity are very important, but they're not always present when it comes to force. We've got some other things up here, though, that are always present. Motion. Is motion always present? Now, I want you to think about that. Okay? That's who haven't I called on in a little while? This young lady.
Okay, if you have like a balanced force, and one thing's pushing against one thing, the side of something, and something else is pushing in the same amount, it wouldn't move because the same force is
Right. So is motion always present? Because think about it. If I'm pushing this way and I'm pushing this way and I'm pushing the same, is there motion? Are there forces though? Okay. So let's put motion under what? Where should that go? Sometimes present. Okay. Now there's a lot of things up here. There's some stuff that goes under always present.